Okay, so this is 8th grade Common Core number 13, and this is going to be solving two-step equations. We talked last time about solving one-step equations. Two-step equations are just going to be putting together the different steps on adding, subtracting, multiplying, and dividing, and we're going to be using those to solve equations. Remember, equation has an equal sign and variables as well. You should have written your objective from your Canvas notes. It should read something along the lines of, I can solve I can solve two-step equations. Okay, so you want to copy your objective, you're going to write that down, and you're going to make sure that you have identified the vocabulary before you have started this. So if you have not identified your vocabulary, it would be a good idea to stop now and identify that vocabulary and then continue. Okay, we're going to continue to do these by example. So let's go ahead and talk about that. If some of you are confused too, in this might be 1.14, but it is item number 13. So let's look at some examples, and we're going to explain these, and we're going to go through a few examples, and hopefully you'll remember all that we did in 7th grade, and you're like, oh yeah, that's how I do two-step equations. So let's start with 2x minus 5 is equal to 11. Alright, so the first thing I'm going to do is I'm going to add or subtract if there's a constant by itself. So I'm going to write that out. Add or subtract if a constant, which means there's a number not attached to the variable, is by itself. So let's look at that equation. Is there a constant that's by itself? There sure is. There's a negative 5 hanging out there all by itself. So in order to get rid of that negative 5, we're going to do the exact opposite of what is there. So the opposite of minus 5, is plus 5, right? So we're going to add 5 to both sides. Remember, whatever we do to one side, we must also do to the other. Okay, these negative 5 plus 5 can cancel out. So this becomes a 2x equal to 11 plus 5 is 16. Now you should see that this is an easy one-step equation. So now in order to isolate the variable, which is our next step, we're going to multiply or divide, depending on how that number is connected to the constant, to isolate the variable. Okay, and of course I say that too much. So you see here that we have a 2 connected to the x. The 2 and the x are connected through multiplication. The opposite of multiplication is division, so we're going to divide both sides by a 2. These 2's cancel out, and that's going to leave us with x is equal to 16 divided by 2, which happens to be 8. Okay, and we're going to follow these same steps each time we work with a two-step equation. So let's say this was number 1. Let's work with a second one. Well, let's see. How about 10 equals 6 minus 2x? All right, well, that seems easy. Here we have these things. First, we say add or subtract if the constant is by itself. So the constant here that's hanging out by itself is just the 6. Okay, well, that is added because there's nothing over here that says minus. That's added to the 2x, so we're going to subtract 6 from both sides, leaving us with 4 is equal to negative 2x. And then we're going to multiply or divide to isolate the variable. Well, a negative 2 is attached to the x by multiplication, so we're going to divide both sides by a negative 2 to undo the multiplication, which leaves us with a negative 2 equal to x, and that is our answer. Okay, remember when we're putting it into Canvas, we're always going to put the variable on the left side. So that's easy. When we're dealing with whole numbers or integers, it's a lot easier. But what happens when we deal with fractions? And you guys are probably going, fractions, I hate fractions. But actually, we have an easy way to deal with fractions, and that is a way that makes the fractions kind of go away. Okay, so contains fractions. So I'm going to make this my 0 step. The first thing I'm going to do before I add or subtract, if the constant is by itself, the first thing I'm going to do is say, hey, are there fractions? So we're going to make that a 0 step. Are there fractions? Okay, and of course on this one I'm going to give you one that has fractions in it to kind of make sure we know what we're doing. So let's look at this. This one is x divided by 15 is minus 1 over 5 is equal to 3 over 5. Well, the first thing I want to do, if it's all possible, I like to get those fractions out of there because I don't like fractions. So if the answer is yes, there are fractions. Here's what we're going to do. We're going to multiply both sides by the LCD, or the least common denominator. Okay, so let's say we have 15, 5, and 5. Well, I know that 15 goes into itself 1 time, and I know that 5 goes into 15 3 times, so those will work as our 15 will work as our least common denominator. So we're going to multiply everything by 15. We're going to multiply this side by 15, and we're going to multiply this side by 15. So that becomes 15 over 1, because we want to make it a fraction to make it for easy cross canceling, which is our next step, times x over 15 minus, and we have to do it to every term, so make sure we do this 15 times the next one, right? 15 over 1 times 1 over 5 is equal to 15 over 1 times 3 over 5. Okay, so our first step here was to multiply by both sides by the least common denominator. Our second one is going to be to cross cancel. If we cross cancel, it's going to make it a lot easier, right? Because when I see these two here, I can say, oh look, that is just 15 times 15, those cross cancel. So I'm going to cross these out because they each go into each other once, so we're going to make those ones. And 15 and 5, well, those can be divisible by 5, so that leaves us a 3 here and a 1 here. These two cross cancel, that's going to leave us with a 5 here and a 3, a 3 here and a 1 here. So if we go through and we multiply that all out, now we have x minus 3, because it's just x here and 1 on the bottom. We can leave those ones off. 3 times 1 is 3, and 1 times 1 is 1, and we can leave that off, so that's x minus 3 equal to, and then we can solve this here. We have 3 times 3, which is 9, and 1 times 1, which is 1, so we can leave that. Now look at that. We have a one-step equation. We can just add 3 to both sides, and then we have x is equal to 12. So if we go through and we multiply by the least common denominator, it's going to make it a lot easier for us. I'm out of room, so I'm going to go ahead and flip to the next page so I can do some more examples for you. So if you need to have some time to stop, that's fine. If you don't, go ahead and follow along with me and just flip. If you need more time, go ahead and pause the video. Otherwise, go ahead and flip your paper. Okay, this is the same number 13. I'm just going to give you a few more examples to make sure this totally sets in your head. Okay, and for the next example, I'm going to say, okay, what about x over 4 plus 2 equal to 9? Well, there really aren't fractions. It kind of looks like there's fractions, but really this is a division sign. This is just x divided by 4. If there were fractions on my constants, I'd go ahead and multiply by the least common denominator. But since it's only here, this is actually a division sign. So I say, okay, are there variables or constants hanging out by themselves? There sure is. There's this one that's attached to the x, because our main goal is to isolate x and solve it for x, right? How is that 2 attached to that x? Well, it's multiplied. So in order to get rid of multiplication, it's not multiplied, it's added. So in order to get rid of addition, I'm going to subtract 2 from everything on both sides. That's going to leave me x over 4 here, and it's going to leave me 7 on this side. Okay, now I say, well, how is the x and the 4 connected? Well, that's easy. They're divided. So in order to get rid of the division sign, I'm going to multiply each side by 4. These two cancel out and become 1, so x is equal to 7 times 4, which is 28. Okay, let's try one last one, and this one I think there might be some fractions, so you'll see me deal with fractions one last time. So we have 3 over 4x plus 1/2, which is equal to 7/2. Okay, so there's those fractions again, but let's just wipe them out, not just stop them, but we can get rid of them by multiplying everything by the least common denominator. Well, I know that 2 times 2 is 4 and 4 times 1 is 4, so I'm going to use 4 as my least common denominator, which means I'm going to multiply everything, every term inside these giant parentheses by a 4. So that would leave us 4 over 1 times 3 over 4x plus 4 over 1 times 1/2 x, because remember we have to distribute that 4 to every single term inside the parentheses, which is what we're doing right now. 4 over 1 times 7 over 2. Okay, and remember from what we wrote before, after we've distributed, now we can cross cancel. So we can say that's right. If we look here, these two become a 1. These two, well, this 2 goes into 4 twice, and 2 goes into itself once. We can cross cancel these. 2 goes into 4 twice, and 2 goes into itself once. When we went through and finished that multiplication, now we have 1 times 3x, which is just 3x, over 1, which we don't need to write, plus 2 times 1, which is 2, over 1, again, we don't need to write it, which is equal to 2 times 7, which is 14, over 1, which we again don't need to write. Now we have a simple two-step equation. We have a variable hanging out by itself, which is plus 2. We can subtract 2 from both sides. These two cancel out. That's going to leave us with 3x is equal to 12. Now we're going to multiply or divide to isolate the variable. We're going to divide because the 3 is attached to the x with multiplication. We're going to divide both sides by a 3, leaving us with x is equal to 4, and that is going to be the solution to our equation. Now, you can go ahead and watch more videos that are on Canvas if you think it'll help you, and you're going to go ahead and do the homework, which is going to be in your Canvas assignment. If you need any help, go ahead and ask me or email me. Otherwise, good luck.